Hey everyone, welcome back. In this video I'm going to explain how to test and diagnose the transmission when you have P0705 transmission range switch circuit malfunction. So this fault code is related to the transmission range switch, or what sometimes we call it inhibitor switch. Inhibitor switch is located right here on the transmission, and anytime that you shift the gear between park, reverse, neutral and drive, you're actually changing the position of this transmission range switch. And transmission control module keeps checking the output signals from this transmission range switch to understand the driver intended gear shifter position. And of course, based on that, it's going to control the automatic transmission operation. So basically, when you have this code, there could be different possible causes, including the transmission range switch itself, the connector on the transmission range switch, wiring, or even transmission control module could be the cause. In this case, I have engine and transmission control module in one unit, so I call it PCM, which is powertrain control module. Let's have a look at the wiring diagram first. Before starting to diagnose the component, there are two pins on the right for park neutral switch, which normally is used for starting system to prevent the starting system to crank the engine when transmission is located on reverse or drives. As you know, on automatic transmission, we are only able to crank the engine when transmission is located on park and neutral, and this switch is going to help us to do that. And there is one power supply, which is pin number 3, and we have 4 signals for different positions on gear shifter, park, reverse, neutral and drive. So today I'm going to show you how to test them one by one. So basically, PCM monitors the output signals from transmission range switch to see what is the position on the gear shifter right now. So in this video I'm going to show you how to test the transmission range switch with the scan tool, how to test it with the multimeter. I will explain the wiring diagram as well, step by step, how to test each single wire over there on transmission range switch. So if you have the scan tool, you can use this section for diagnosing the transmission range switch with the scan tool. I'm going to show you how to do it. So select the car. So I go for the system selection, transmission control module. So right now we need to go for the data stream, current gear, shift lever switch. So as you see, I have these two options. Gear shifter switch is on park right now. So as you see, the gear shifter is on the park. So check the live data. I'm gonna shift from the park to reverse. Okay, reverse. As you see, gear shifter on the reverse, and live data showing the reverse as well. So I'm gonna shift to neutral. Neutral, as you see, it's already on the neutral, and later on I'm gonna shift to drive. So as you see, transmission is receiving the signals properly, so it means everything is working in order and in a proper way. But if you are reading the live data right now and you see one of them or all of them not accurate, it means something is going on with transmission range switch that you need to follow up the diagnostic to get it fixed. All right, back on the transmission range switch. Before starting to do the diagnostic, we need to identify the wires to see which one must be inspected. So if I disconnect the connector, so you see the connected details on the screen as well right now. To locate the pins on the connector, pin number 1 and 2, these two are actually for the park neutral switch for a starting system. Pin number 3, this pink wire, this one is actually the power supply coming on neutral switch. And as you see on the screen on the wiring diagram, this one gets the power supply from a fuse inside the IP junction box. So if that fuse is broken, of course you won't have any power supply over here as well. So pin number 4, this is a signal number 2, and I will explain what is the signal number 2 later on. So we do have 3 more pins, these 3 more pins. The green one is pin number 7 for signal number 3. The brown one at the middle here, number 8, this is signal number 1, and signal number 4 is actually this pink wire located just right here. So we have 4 positions for 4 signals on gear shifter, and of course here on transmission range switch. So the first thing that you need to check is the power supply. As I explained to you, this pin number 3 is the power supply over here. So when ignition switch is on, you can test it like this. You see the procedure on the screen. Basically, you need to check the power supply between pin number 3 and the body ground when ignition switch is on. All right, multimeter on the voltage. I'm gonna check the voltage on pin number 3, which is the power supply, between here and the body ground. So as you see, I'm getting battery voltage, which confirms that the voltage is provided on the transmission range switch. So if you don't have the power supply over here, you need to chase this wiring back. You need to check this wiring all the way from here to the fuse box or the fuse as well, to make sure what's the problem for this wire to get it fixed. But if you do have the power supply, you need to go to the next step to check other wiring. So the next step is going to be checking the output voltage for each signal. As you remember, we have 4 signals. We need to check the output voltage for each signal. But first of all, we need to see which signal is related to what position on the gear shifter. So as you see the table on the screen, we have signal 1, 2, 3 at the top, and the gear shifter position on the left, park, reverse, neutral, and drive. As you see, we have 12 volts on signal 1 when gear shifter is positioned on park. And for signal 2, we will have 12 volts when transmission is located on the reverse. Signal 3 is for the neutral position, which gives us 12 volts in neutral position. And if you put the gear shifter on drive position, we will have 12 volts from signal 4. As you see, in all other conditions, these switches are sending actually 0 volts. For example, right now, I need to back probe these ones because I need to put the connector back when I'm actually performing the test. So the first thing is the signal 1. And as you see on the screen, signal 1 is actually the brown wire number 8. So here's the brown wire number 8. I'm gonna back probe this. Okay, I did back probe it. I need to put it back on the range switch. So transmission is already on the park position. So if I test the voltage right now, I should have battery voltage. So I put the multimeter on voltage and I check the output voltage of signal 1. As you see, I'm getting battery voltage. It means the output voltage for signal 1 for the park position is actually okay. But let's see what's gonna happen if I shift the gear from park. Of course, this voltage should drop to 0. Let's have a look. As you see, I put the transmission on reverse and voltage is already dropped to 0. So right now I can check the other pin for the reverse. So as you see, signal 2 is for the reverse, which is pin number 4, a red wire. So pin number 4, a red wire, is just right up here. I'm gonna back probe that one too. And transmission is already on the reverse. Voltage, and I'm gonna read the voltage from here. So as you see, I'm getting battery voltage right now, which confirms the output voltage of signal 2 for reverse position is okay. And the next one is gonna be signal 3. So signal 3 is this green wire. I'm gonna back probe it. And then let's connect it back. So signal 3 is for neutral. So if I check the voltage right now, I don't have any reading right now because transmission is on the reverse. Let's put it on the neutral and see what happens. We are getting battery voltage, so it means the output voltage for signal 3 or neutral position is okay as well. And the last one is signal 4. Signal 4 is a pink wire pin number 9, which is just a pink wire pin number 9, which is just right here. All right, so I put the connector back. and read the voltage again. So we are not getting anything right now. Let's put the transmission on drive and see what happens. Transmission on drive, we are getting the battery voltage right now, which confirms that the output voltage of signal 4 for drive position is just fine. So if you are testing in any steps, if you are testing the output signals, because we are actually checking directly on the range switch, if you're checking the output signal in any steps and you see one or more signals are not exactly same as the specification inside the workshop manual, it means the range switch itself is faulty. Of course, before that, you need to make sure the connector itself is okay as well. There is no dirt, moisture, or corrosion inside the connector. So because you want to make sure your reading is accurate. So if the output signal over here is not okay, you have to replace the transmission range switch. But if you see the output voltage here is okay, but you still have the fault, you need to check the wiring on the other end, on the ECM side, because you may have the wiring problem or PCM problem, but you don't know which one is faulty right now. So you check the wiring one by one. If you find the open circuit or short circuit on the wiring, you get it fixed. But if the wiring are okay, you still have the fault, the problem could be from your PCM. Alright guys, thank you very much for watching. I hope you enjoyed the video. Please don't forget to visit the channel page for more diagnostic videos and subscribe the channel for getting the notification in case we upload more diagnostic videos.